You cannot see an atom with visible light. The wavelength is 3,000 times too large. The tool is too big for the task. This is how scientists broke the laws of physics to see atoms from electron waves to magnetic lenses to solving an impossible problem. Light's wavelength ranges from 380 to 750 nanometers. An atom is just 0.1 nanometers. Light simply diffracts around it. The solution came from electrons, accelerated to 80% light speed. Their wavelength shrinks to 2 picometers, small enough to see atoms. Glass lenses cannot focus electrons. The breakthrough was electromagnetic lenses. Moving electrons spiral through magnetic fields, focusing to a point. But there was a fatal flaw. Spherical aberration. Outer electrons bend too much, creating blur. The image gets worse as magnification increases. In optics, you add a diverging lens to cancel the aberration. But for magnetic lenses, this is physically impossible. Maxwell's equations forbid it. The solution was radical. Break the symmetry. A hexapole magnet distorts the beam into a triangular saddle, creating a tiny divergence. A second hexapole unbends the image. The circular beam now carries remnants of that divergence, perfectly cancelling the spherical aberration. After 60 years, atoms became visible. What was once impossible is now standard in labs worldwide. We can finally see reality itself.